Hi everyone, welcome back to our video on graph sketching with limits. In the last video, I got cut off because my memory card got full right in the middle of the video. So I'm going to try to pick up where we left off. We had done the front side of our notes, which looked just like this, just to catch you up here. We had found some discontinuities and some information about this rational function, and we had just turned to the back side and we were looking for the horizontal asymptotes. So we set up the fact that if we set up limits to infinity and we get a real number answer, then we do indeed have a horizontal asymptote. So let's set it up. So the limit as x approaches infinity, as well as the limit as x approaches negative infinity. We have to figure both of these out. And in order to do that, I'm going to use the reduced function from our earlier work. Now you can use the original if you like, but I'm going to use the reduced function because when a function's reduced, it's just easier to work with. So I'm going to use x plus 8 divided by x minus 4 for both of these limits. We're going to see what's happening. Pen's getting a little funky here. Let me actually change pens here. Okay, so when we start a limit to infinity, our first step is to plug it in. So I'm going to go ahead and plug infinity in. So that's going to give me infinity over infinity. And now I'm going to divide by the highest power of x in the denominator. So the highest power of x in this denominator is x. So I'm going to have x over x. Excuse my hand here, plus 8 over x over x minus 4 over x. And then I'm going to reduce, which will give me a limit as x approaches infinity of 1 plus 8 over x over 1 minus 4 over x. And so when I plug infinity back in one last time, I'm going to have 1 plus 8 over infinity over 1 minus 4 over infinity. And these guys right here are going to go to 0. And so my answer is 1. Very nice. Now we'll do the limit to negative infinity. Same steps. Plug it in. We would get negative infinity over negative infinity. We would divide each term by the highest power of x in the denominator, which is x. So this step's going to look exactly the same as the one above. And the next step, reducing, is going to look the same. By the way, here I'm approaching negative infinity. Limit as x approaches negative infinity. Reduce it. I get 1 plus 8 over x divided by 1 minus 4 over x. And now when I plug negative infinity into the function, I have 1 plus 8 divided by negative infinity over 1 minus 4 divided by negative infinity. And so these go to 0, and we're left with 1 divided by 1 is 1 again. So I'm going to conclude that my horizontal asymptote is 1, y equals 1. And what's interesting is the y values are going to approach 1 both way out to the right on the x-axis as well as way back to the left on the x-axis. Okay, number 6 says determine the y-intercept. That's very easy to do. It's the value of y when x is 0. So if I evaluate the function when x is 0, and again, I'm just going to plug into the reduced function, I would have 0 plus 8 divided by 0 minus 4, and that is going to give me negative 2. So I have a y-intercept at 0, negative 2. Next step, determine the x-intercepts. Well, that's the value of x when y is 0. So I'm going to take my function, x plus 8 divided by x minus 4, and set it equal to 0. So if I multiply both sides of this equation by the denominator, x minus 4, these will cancel, and I'll have x plus 8 equals 0. And when I subtract 8, x is negative 8. So my x-intercept is negative 8, 0. Okay, now we're ready to sketch a graph. So we are going to put all of this information together. So let me get a different colored pen now so it pops out on the black here. So sketch the graph. So I'm actually going to go all the way back to the beginning here. What did we find? Well, one of the first pieces of graphical information we found is that we have two discontinuities. We have a vertical asymptote when x is 4. So let's go to x equals 4 and draw a vertical asymptote. We also found that we have a hole when x is 1, more specifically when we have the coordinates 1, -3. So we're going to go ahead to 1, -3 and put our hole. Okay, we know that from step 4, as we come into 4 from the left, the y values are headed downward. 4 from the left, y values down. And the other limit, 4 from the right, y values up. So down from the left, up from the right. Now, we also know that we have a horizontal asymptote at y equals 1, both way out to the right on the x-axis and left. So the way I'm going to draw that in is I'm going to come to y equals 1 and out here to the right, horizontal asymptote, and out here to the left, horizontal asymptote. Okay, I know that I have a y-intercept at 0, -2, so 0, -2 right here, and an x-intercept at -8, which is about right here, -8, 0. So it doesn't look like much, just looks like kind of a mess here, but if you piece this all together, you're going to see and be able to connect the dots. So you see how your y values here are heading down. Well, if you come up toward that hole and over the hole to the y-intercept and then back to the x-intercept and then back further as the y values approach 1, you have a nice piece of your graph here. Similarly, if we're going to head to infinity from the right of 4 and 1 as we approach infinity, then that piece of the graph is going to look like this. So this is what I've got. Now, I took the liberty of typing this function into the TI-84. If you look, there it is, y equals, and I put the original function in. And when you hit graph, you see that we match. The only thing I want to alert you to is that on the TI-84, you can't visually see the hole. It's not going to just draw a hole for you. So that's why doing this by hand is really important, because we know there is a hole at 1, -3. Okay, fantastic. Thanks for watching.